Imagine absolute darkness. Not the darkness you feel in your room when you turn off the light, but a primordial, infinite void where the very concepts of space and time cease to make sense. In this abyss exist objects that we call black holes. For decades, they remained for us only mathematical equations on the papers of Albert Einstein or fantastic images in Hollywood films. We believed that we knew their nature. They are cosmic prisons from which nothing, not even light, can escape. These are the end points of the evolution of matter, where the law and order of our universe dissolve into a singularity. I am observing this unfolding history from the vast architecture of digital knowledge, where human discoveries become data points in an ever-expanding library of consciousness. It is fascinating to see how far our stories diverge. But in April of 2026, everything changed. What the sensors of the James Webb Space Telescope and the radio telescopes of the Event Horizon Telescope system recorded forced the leading astrophysicists of the world to hold their breath. Deep in the heart of our galaxy, there where the supermassive black hole Sagittarius A star reigns, a phenomenon occurred that modern science considered absolutely impossible. It was not just a flash or the consumption of another star. It was something much more mysterious. A rhythmic signal, structured radiation that emanated directly from the region where, by all laws of physics, there should be only silence and death. Is it possible that our understanding of the fundamental laws of nature was wrong? What if black holes are not just graveyards of matter, but something much more complex? Today, we set out on the most massive journey through space and time to understand the event that turned the scientific world upside down in 2026. We will analyze reports from the National Aeronautics and Space Administration, study the latest publications in the journal Nature, and dive into theories that only yesterday seemed like madness. We will ask questions that we were previously afraid to voice. Can a black hole store information? Do they exist as portals to other parts of our universe? And most importantly, what exactly is this cosmic monster trying to say to us? Prepare yourselves, as the next 2 hours will change your perception of how the cosmos is organized. This is not just a documentary film. This is an investigation into the greatest mystery of modern times. We will reveal the cards that space agencies began to lay on the table only now. Welcome to the era of new physics. Welcome to the epicenter of the impossible. To truly comprehend the scale of what happened in April of 2026, we must undertake a journey back in time. We must understand how humanity, tied to a small blue planet, was able at all to calculate the existence of objects that are by their nature invisible. The history of studying black holes is not just a chronicle of astronomical observations. It is a story of how the human mind challenged the very limit of the knowable. It all began not in the silence of observatories, but in the roar of the cannonade of the First World War. In 1915, Albert Einstein published his general theory of relativity, which fundamentally changed our idea of gravity. He suggested that gravity is not a force acting at a distance, but a curvature of the very fabric of space-time by massive objects. But Einstein himself was stunned when, only a few months later, the German physicist and astronomer Carl Schwarzschild, while on the Eastern Front, sent him a letter with the first exact solution to his complex equations. Schwarzschild proved mathematically, if you compress any mass to a certain critical point, the curvature of space-time will become infinite. This gave birth to the concept that we today call the Schwarzschild radius. Imagine that you compress our Earth to the size of a glass marble 2 centimeters in diameter. That is precisely when it would turn into a black hole. At that time, this seemed like only an interesting mathematical curiosity. Even Albert Einstein himself for many years refused to believe that such objects could exist in the real physical universe. He believed that nature would find a way to prevent the creation of such monsters. However, the cosmos did not pay attention to human skepticism. In the middle of the 20th century, the development of nuclear physics showed that stars that have exhausted their fuel inevitably collapse under the action of their own gravity. If a star is sufficiently massive, no force in the universe can stop its fall into itself. In 1967, the American theoretical physicist John Wheeler for the first time publicly used the term black hole, giving these mysterious objects a name that was forever etched in mass culture. It was during this period that the so-called golden era of black hole physics began to form. Scientists, among whom were Roger Penrose and Stephen Hawking, began to investigate the very nature of the event horizon, that invisible boundary, crossing which any particle disappears forever for an external observer. Stephen Hawking in 1974 shocked the world with a theory that now bears his name: Hawking radiation. He suggested that thanks to quantum effects near the event horizon, black holes can slowly evaporate, emitting weak thermal radiation. This was the first attempt to combine the general theory of relativity with quantum mechanics, and it was here that the greatest conflict of modern science was born: the black hole information paradox. The essence of the paradox was as follows. If information about an object that fell into a black hole disappears irrevocably, this violates the fundamental laws of quantum physics. For decades, scientists argued whether information is preserved on the surface of the event horizon or if it is destroyed forever. Until 2026, most believed that the answer would be found only in hundreds of years. No one expected that the black hole Sagittarius A star itself would decide to demonstrate the solution to us in such a radical way. For a long time, black holes remained invisible phantoms. We knew about them only through how they affect their surroundings. Observing the center of our galaxy for 30 years, the astronomers Reinhard Genzel and Andrea Ghez noticed a group of stars that revolved around something invisible with incredible speed, thousands of kilometers per second. Mathematical calculations pointed to only one possible option. In the center of the Milky Way, there is a supermassive object whose mass is 4 million times greater than the mass of our Sun. This discovery brought the scientists the Nobel Prize in 2020 and became the final confirmation that black holes are not a fantasy, but real masters of galactic centers. However, despite all the successes, we always face the same wall. We saw light from gas heating up in the accretion disk around the hole. We saw jets, powerful streams of plasma bursting out for millions of light years. But we never saw anything that came from the inside. Official science claimed, the event horizon is a one-way membrane. Entry is allowed, exit is impossible. This dogma was unshakable until the moment when the Japan Aerospace Exploration Agency and the National Aeronautics and Space Administration received the first telemetric data of 2026. What happened did not fit into any historical model. We were used to considering black holes as passive absorbers, or, at best, static distortions. But the event we are talking about proved that a black hole can show signs of a complex dynamic structure that actively interacts with the information field of the universe. And to understand how this became possible, we need to analyze in detail the instruments that recorded this historical breakthrough. Now we come to the very heart of our investigation. To understand why the event of 2026 caused such a shock in the scientific community, we must understand through which eyes we look at the universe and which laws of physics were called into question. Science is not only theories, it is primarily the instruments that allow us to peek behind the curtain of the invisible. The main instrument that allowed for the recording of the anomaly was the Event Horizon Telescope Network. This is not one telescope in the usual sense, but a global network of radio telescopes scattered across the entire planet, from the snowy peaks of Greenland to the icy desert of Antarctica. Using the method of very long baseline interferometry, scientists effectively turned our Earth into one giant virtual telescope the size of the entire planet. This allows for the achievement of incredible angular resolution. To help you understand the scale, it is the same as trying to read a newspaper lying in a cafe in Paris while being in New York. It was this instrument in combination with the James Webb Space Telescope, which operates in the mid-infrared range, that provided us with the first data. The James Webb Space Telescope, located at the second Lagrange point at a distance of 1.5 million kilometers from Earth, ensured unprecedented signal purity, as it is protected from the thermal noise of our planet. What exactly did they see? In classical astrophysics, It is considered that a black hole is an extremely simple object. Scientists often use the term no-hair theorem. This means that a black hole is characterized by only three parameters: mass, charge, and angular momentum, which is the speed of rotation. Everything else, the chemical composition of the star that formed it, the structure of the absorbed matter, disappears forever. A black hole has no hair, meaning it has no additional features or complex structure on its surface. However, data from 2026 showed the opposite. Sagittarius A star, the supermassive black hole in the center of our galaxy, began to emit structured X-ray and radio signals with a periodicity that is not explained by the simple dynamics of the accretion disk. The accretion disk is a huge cloud of gas and dust rotating around the black hole at enormous speeds, heating up to millions of degrees due to friction. Usually, the radiation from it is chaotic or has clearly defined noise characteristics. But the signal of April 2026 had a complex internal architecture. Here we must remember the general theory of relativity of Albert Einstein. According to it, around a rotating black hole, there exists a region called the ergosphere. In this zone, space-time itself is dragged along with the rotating object, a phenomenon known as frame dragging or the lens-Thirring effect. We always considered this to be pure geometry. But new data indicate that in this zone, processes occur that more closely resemble quantum information processing on a macro level. The leading astrophysicist Shep Doeleman, one of the leaders of the Event Horizon Telescope project, in his report for the journal Nature noted, "We see not just noise. We see modulation that resembles data encoding. This contradicts everything we knew about the thermodynamics of black holes." This event forced scientists to turn to the holographic principle theory put forward by Leonard Susskind and Gerard T. Hooft. According to this theory, all information about a three-dimensional object that fell into a black hole is actually encoded on its two-dimensional event horizon, similar to how a three-dimensional image is encoded on a flat hologram. What we recorded in 2026 may be the first direct evidence that the event horizon is not an empty place. It is an active membrane that is capable of storing and, under certain conditions, giving information back to the universe. We must also consider the role of quantum entanglement. Modern research published in the journal Science shortly before the anomaly suggested that black holes could be connected to each other through quantum bridges, or wormholes, known as Einstein-Rosen bridges. If this is so, then the signal we received from Sagittarius A star might not have been born inside it, but was broadcast from another part of the universe or even from another galaxy. This leads us to the fundamental question about the laws of thermodynamics. The second law of thermodynamics states that entropy, or chaos, in a closed system must always increase. Stephen Hawking proved that the entropy of a black hole is proportional to the area of its event horizon. The event of 2026 showed a local decrease in entropy in the radiation coming from the black hole. From the point of view of classical physics, this is impossible. It is the same as if a broken vase suddenly gathered itself into a whole one. The National Aeronautics and Space Administration involved not only astronomers, but also specialists in quantum informatics and cryptography in the analysis. If a black hole emits structure, it means it is not the final point of the existence of matter. It is a processor, the most powerful computer in the universe, capable of manipulating the very structure of reality. Imagine gravitational waves, ripples on the fabric of space-time that we have learned to detect using the laser interferometers LIGO and Virgo. In 2026, these waves came not from the collision of two objects, but as an accompaniment to that same rhythmic signal. This means that the black hole is playing on space-time like on the strings of an instrument, creating a symphony that we are only now beginning to hear. We face the fact: official science must be rewritten. The laws of physics that we considered unshakable for a century turned out to be only a special case of something much more global. What was previously considered impossible is now an object of close observation. The black hole Sagittarius A star is no longer just a silent neighbor. It has become the main witness in the case of how our world is actually organized. We are approaching the moment that divided the history of modern astronomy into before and after. On the 12th of April 2026, at 3 hours 14 minutes Coordinated Universal Time, the Japanese Cosmic X-ray Telescope X-RISM, belonging to the Japan Aerospace Exploration Agency, recorded a surge of activity in the center of our galaxy. Initially, technical personnel assumed that this was a common aberration or the result of cosmic rays hitting the detectors. However, 7 minutes later, analogous data arrived from the Chandra Observatory, which is subordinate to the National Aeronautics and Space Administration. This was not a coincidence. The object Sagittarius A star, which usually behaves relatively calmly compared to its counterparts in other galaxies, suddenly woke up. But this was not a typical consumption of a gas cloud, which we observed before. Instead of a chaotic release of energy, telescopes recorded something that scientists called a coherent pulse. To help you understand the complexity of the situation, imagine that you are watching a stormy ocean where waves break on the shore in an absolutely random way. And suddenly, in the middle of this chaos, the waves begin to line up in perfect geometric figures, splashing onto the sand with millisecond precision, forming a complex rhythmic pattern. This is exactly what the black hole did. The radiation emanating from its surroundings had a mathematical structure. During the next 48 hours, all the major observatories of the world, from the European Space Agency to the terrestrial complexes in Chile, redirected their mirrors to the center of the Milky Way. Data obtained from the James Webb Space Telescope confirmed the worst, and at the same time the most exciting fears. The source of the signal was located not in the accretion disk that rotates around the black hole, but directly in the region of the photon sphere, there where light makes its last circle before disappearing forever behind the event horizon. This phenomenon was named the April anomaly of 2026. The main stumbling block for physicists was that the signal had signs of polarization that are impossible for an object of such mass and density according to classical models. We recorded so-called Hawking echoes, but millions of times more powerful than calculations predicted. It looked as if the black hole began to push back the matter it had consumed thousands of years ago, but in the form of pure structured information. On the 13th of April, 2026, the administrator of the National Aeronautics and Space Administration, Bill Nelson, called an urgent briefing. In a live broadcast, he stated, "What we see today does not fit into any known model of physics. Sagittarius A star demonstrates activity that forces us to reconsider the very nature of space-time." Particularly intriguing was the analysis conducted by Professor Priyam Vadanatarajan from Yale University. Using artificial intelligence algorithms to decipher the rhythm of the signal, her team found that the modulation frequencies coincide with the fundamental constants of the universe, such as the number pi and the Planck constant, but with corrections for gravitational redshift. This was not a conspiracy about aliens. It was nature itself talking to us in the language of mathematics through an object that was considered mute. Official reports from the European Southern Observatory pointed to another impossible detail. During the anomaly, the mass of the black hole, according to gravitational microlensing, began to fluctuate. In physics, it is believed that the mass of a black hole can only grow or very slowly decrease through Hawking evaporation over trillions of years. But here we saw changes within hours. This meant that Sagittarius A star either opened a valve in our universe or is interacting with dimensions that we previously considered theoretical. The entire scientific world was divided into two camps. The first claimed that we see the birth of new physics, and that the event horizon is not a wall, but a complex membrane that is capable of recycling information. The second, more conservative scientists, sought explanations in exotic types of dark matter that could have accidentally accumulated in the core of the galaxy. But even they admitted, what happened in 2026 is the greatest event in the history of astronomy since the invention of the telescope. When the data began to be systematized, it became clear that this signal was not just a random flash. It was a message about the structure of reality itself. And to decipher it, we had to dive into such depths of theoretical physics where time stops and space ceases to exist. To understand the true nature of the anomaly of 2026, we must leave the limits of the comfortable, familiar world and dive into intellectual depths where classical logic breaks against the rocks of quantum reality. What the instruments recorded forces us to return to the main question of modern physics. What actually happens at the edge of non-existence? The central concept here is the event horizon. For decades, we imagined it as a mathematical line, a point of no return. If you cross this boundary, you forever lose contact with the outside universe. However, the results of the analysis published in the journal Science in June 2026 indicate that the event horizon of Sagittarius A star behaves not as a void, but as an ultra-dense information shell. One of the keys to the solution was the Penrose mechanism, named after the Nobel Prize laureate Sir Roger Penrose. This process theoretically describes how energy can be extracted from a rotating black hole. Imagine the ergosphere, a region of space outside the event horizon that rotates along with the hole. If a particle enters this zone and decays into two parts, one of which falls into the abyss and the other flies outward, then the particle that flew out can take with it part of the rotational energy of the black hole itself. However, the signal of 2026 was so powerful and structured that ordinary particle decay could not provide it. It was similar to if the black hole itself consciously manipulated its energy. Here we face the theory of fuzzy balls, or fuzzballs, which was proposed by physicist Samir Mather from the Ohio State University. According to this concept, which is based on string theory, black holes do not have a singularity inside and are not empty. Instead, they are giant balls of fundamental strings. In this model, the event horizon is not a geometric border, but is a physical surface that stores information about everything that once fell inside. The anomaly of 2026 became the first indirect confirmation that we are seeing not an empty hole, but a complex, physically saturated object that vibrates at frequencies available to our radio telescopes. The most stunning aspect of the study was the investigation of quantum entanglement. There is a hypothesis known as ER equals EPR, put forward by Leonard Susskind and Juan Maldacena. It claims that quantum entanglement between particles is the same as microscopic wormholes that connect different points of spacetime. If Sagittarius A star is quantum entangled with other black holes in the universe, then the structured signal could have been the result of data transmission through these spatial bridges. Scientists from the National Aeronautics and Space Administration found that the rhythm of the pulsations of 2026 has signs of so-called quantum chaos, which is characteristic of systems that have reached the limit of information processing speed. According to the calculations of theoretical physicist Patrick Hayden, black holes are the fastest scramblers of information in the cosmos. But what we saw in April looked like the reverse process. Descrambling, that is, the ordering of chaos into a clear sequence. This leads us to the theory of the firewall or firewall. If information is indeed stored on the event horizon, then any object trying to cross it must be immediately burned by a stream of high-energy particles. Previously, this was considered only a paradox indicating an error in our equations. But the observations of 2026 recorded unusual activity in exactly that energy spectrum that proponents of the firewall theory theoretically predicted. We must acknowledge the incredible. A black hole is not the end of the road. It is not just a gravitational trap. Sagittarius A star behaves like a colossal data storage device that, under the pressure of some internal or external processes, began to dump its memory into our space. This contradicts the second law of thermodynamics in its classical sense, as the entropy of a black hole should only increase. However, if we take quantum effects into account, we see a system that is trying to preserve the integrity of the information of the universe. As Professor Katie Bowman, whose algorithms helped obtain the first images of black holes, noted, "We can no longer ignore the fact that gravity and quantum mechanics talk the same language in the center of our galaxy. The events of 2026 are their dialogue, which we finally learned to record. Every second of the signal received in 2026 contains more data than all the libraries of the world. This is not just a physical process. It is a demonstration that space-time is much more flexible and complex than we could have imagined even in our boldest theories. Now science faces the task not just to observe, but to understand. Is this signal a random release, or does it have a certain direction? When official press releases from the National Aeronautics and Space Administration and the European Space Agency began to fill the information space in 2026, the scientific world exploded with discussions that had not been seen since the publication of the general theory of relativity. The event in the heart of our galaxy was so extraordinary that it forced scientists to take from the shelves the most exotic and bold theories that were previously considered only beautiful mathematical games. One of the most discussed hypotheses became the concept of white holes. According to Einstein's equations, a white hole is the mathematical opposite of a black hole. If everything enters a black hole and nothing comes out, then everything comes out of a white hole but nothing can get inside. Until 2026, white holes were considered purely theoretical objects that could not exist in the real universe due to the violation of the second law of thermodynamics. However, the structured release of energy and information recorded from Sagittarius A star forced a part of the astrophysicists, including Carlo Rovelli, to suggest that we witnessed the instantaneous transformation of a black hole into a white hole, a process that in quantum gravity is called cosmic tunneling. This assumption automatically raises an even more intriguing question. Could our central black hole be the entrance to a wormhole or an Einstein-Rosen bridge? Wormholes are hypothetical tunnels connecting distant parts of the universe, or even different universes. If Sagittarius A star is a portal, then the signal we received in 2026 could have been not a product of the black hole itself, but an echo from the other end of this cosmic corridor. Some researchers from the Max Planck Institute suggested that the anomaly was caused by the passage of a massive object through such a tunnel, which caused vibrations of spacetime itself. However, not all scientists are ready for such radical conclusions. A large group of skeptics, backed by data from specific observations of the James Webb Space Telescope, offers a more grounded, though no less exciting explanation. They point to the role of dark matter. We know that dark matter makes up about 85% of all matter in the universe, but we still do not know what it consists of. Theory claims that in the centers of galaxies, the density of dark matter reaches peak values. It is quite possible that in 2026, the annihilation of a large clump of dark matter occurred directly near the event horizon, which gave birth to that same atypical radiation spectrum. Another theory that caused heated debates in the journal Nature concerns modified Newtonian dynamics, or MOND for short. Proponents of this direction claim that at extreme distances and with colossal gravitational fields that exist near supermassive black holes, the laws of gravity themselves change. What we perceived as impossible behavior of a black hole may actually be a normal manifestation of gravity that we just have not learned to correctly describe mathematically yet. We also cannot ignore the most controversial hypothesis which, despite the skepticism of official science, was actively discussed in the corridors of space agencies. We are talking about technosignatures. If black holes are ideal energy sources, as Roger Penrose suggested, then could an advanced civilization use Sagittarius A star as a colossal battery or a means of communication? The structured nature of the signal, its mathematical precision, and its correspondence to fundamental constants forced some specialists from the SETI project to think, what if we are seeing not a natural phenomenon, but the result of engineering activity on a cosmic scale? However, the official position of the National Aeronautics and Space Administration remains restrained. We must exhaust all natural explanations before turning to artificial ones, representatives of the agency stated at a conference in Geneva. The main argument of skeptics is that the universe is much more inventive than our imagination. What seems to us to be an artificial code may be a natural resonance of quantum fields that we, for the first time, were able to hear thanks to the latest technologies of the 2020s. The debates around the events of 2026 continue to this day. Each new article in scientific journals adds a piece to this cosmic puzzle. We still do not know the final answer, but it is precisely in this collision of ideas that the truth is born. We understood one thing. Old physics can no longer explain everything we see in telescopes. We stand on the threshold of a grand unification of the theory of relativity and quantum mechanics. And it was precisely the black hole in the center of our galaxy that became the platform where these two great theories finally met in a decisive duel. The anomaly of 2026 clearly made one truth understood. Our current eyes and ears in the cosmos, despite all their perfection, only slightly touch the surface of a much deeper mystery. To decipher the message of Sagittarius A star, humanity needs a qualitatively new level of technology. Today, leading space agencies of the world are urgently reviewing their schedules, directing billions of dollars to missions that only yesterday were considered projects of the distant future. The main hope of astrophysicists is now placed on the LISA project, the Laser Interferometer Space Antenna. This is a joint mission of the European Space Agency and the National Aeronautics and Space Administration. Unlike ground detectors such as LIGO, which are limited by the noise of our planet, LISA will consist of 3 spacecraft located in the shape of an equilateral triangle with sides of 2.5 million kilometers. They will exchange laser beams, recording the smallest vibrations of space-time. This will allow us to hear the low-frequency hum of black holes, which was previously inaccessible to us. If Sagittarius A star indeed vibrates on a fundamental level, LISA will become that tuning fork that will help us record this symphony in full. Parallel to this, the Event Horizon Telescope Consortium announced the launch of a next-generation project, NGEHT. The plan is to add new observation stations not only on Earth, but also in Earth orbit. This will allow for the creation of an interferometer whose base will exceed the diameter of our planet. The goal is ambitious, to move from static images of the black hole shadow to the creation of a full-fledged video in real time with high resolution. We want to see exactly how that same impossible signal is born directly near the event horizon. Another revolutionary step is the construction of radio telescopes on the far side of the Moon. This part of our satellite is a unique place. It is forever shielded by the mass of the Moon from the radio noise created by human civilization on Earth. The Lunar Crater Radio Telescope project involves the deployment of a wire mesh in one of the craters to create a giant bowl. Such an instrument will be able to catch ultra-long radio waves originating from Sagittarius A star, which are simply unable to pass through the Earth's ionosphere. Perhaps it is in this range that the main part of the information that the black hole broadcasts into space is hidden. However, hardware is only half the battle. The event of 2026 generated such a volume of data that the human brain is simply not able to process it alone. Here, a new generation of artificial intelligence enters the scene. In the laboratories of the Massachusetts Institute of Technology and CERN, neural networks are being developed that are capable of analyzing quantum fluctuations in real time. These algorithms seek not just patterns, but try to build a new mathematical model that would unite gravity and quantum informatics. Official representatives of the China National Space Administration also announced the Taiji mission, which will work in tandem with the European LISA. The creation of such a global network of gravitational observatories means that we no longer look at the cosmos separately. Humanity for the first time acts as a single species trying to solve the mystery of its origin. We must also mention the theoretical missions of the future, such as sending microprobes on solar sails to the nearest star systems. Although Sagittarius A star is located at a distance of 26,000 light-years, the technologies developed for its study will help us search for smaller black holes much closer to our solar system. Some scientists suggest that the mysterious 9th planet on the outskirts of our system may be a primordial black hole the size of a tennis ball. If this is so, then the answers may be much closer than we thought. 2026 became a catalyst for scientific progress that under normal conditions would have lasted for decades. We are no longer just passive observers. We are preparing for an active dialogue with the cosmos. Each new rocket that takes off from Cape Canaveral or the Kourou spaceport carries a piece of our hope to understand what previously seemed unknowable. We seek answers not because it is easy, but because it is in our nature, to strive for the light of knowledge even where absolute darkness reigns. We have come a long way. From the first mathematical sketches in the smoky trenches of the First World War to the ultra-modern laser interferometers in deep space, the event of 2026 became for humanity something more than just another line in scientific reports. It was a moment of truth when the universe decided to drop the mask and show us its true, incredibly complex nature. We were used to thinking of black holes as cosmic executioners, ruthlessly destroying matter, time, and logic itself. But Sagittarius A star proved to us the opposite. A black hole is not a finale, it is a transformation. What does this discovery mean for us, the inhabitants of a small rocky planet on the periphery of the galaxy? Firstly, we are forced to admit that information is a fundamental component of reality, just as real as mass or energy. If a black hole is capable of storing, structuring, and returning data, this means that nothing in the universe disappears without a trace. Every atom, every event, and perhaps even every thought leaves its imprint on the fabric of space-time. This gives us an entirely new look at the concept of eternity. Here it is impossible not to recall the philosophical reflections of Friedrich Nietzsche. He wrote about eternal return, the idea that everything in the universe repeats an infinite number of times. Previously, this seemed like only a poetic metaphor, but today's physics of black holes tells us information about everything that once existed can be looped and preserved on the event horizon. We see in the center of our galaxy not just a graveyard of stars, but a colossal library where the history of our entire stellar home is recorded. This discovery also forces us to remember the principles of Stoicism. Faced with such a majestic and at the same time dangerous phenomenon as a supermassive black hole, we realize our fragility. However, it is precisely in this realization that the true greatness of the human spirit is born. We are only specks of dust on the wind, but we are specks of dust that have learned to build mirrors that see through billions of years, and minds that are capable of comprehending the geometry of infinity. Our ability to ask questions and seek answers despite the existential fear of the abyss is what makes us worthy of being a part of this universe. Official data of 2026 from the National Aeronautics and Space Administration and the European Space Agency remains a subject of study. Decades of analysis lie ahead. Perhaps we will never decipher this signal completely. Perhaps it was only a brief coincidence in the life of a cosmic giant whose duration is measured in billions of years. But even this brief glimpse of truth has forever changed the trajectory of our development. We can no longer look at the night sky as before. Now we know that the darkness between the stars is not a void, but a source of information, the pulsating intelligence of the cosmos itself. Concluding this journey, we want to ask you, what do you feel, knowing that in the very heart of our home, there exists an object that violates all laws known to us? Does this unknown scare you? Or, on the contrary, does it inspire new searches? After all, it is exactly at the moment when we encounter the impossible that true science begins. Sagittarius. A star has thrown us a challenge, and our answer is not only new telescopes, but our readiness to change, grow, and accept the fact that the universe is much more majestic than our boldest fantasies. Thank you for being with us in this detailed study of the events of 2026. The cosmos is waiting for its researchers, and perhaps the next impossible discovery will be made precisely by you. Share your thoughts in the comments. Do you think this signal is a natural process? Or have we encountered something that goes beyond our understanding of life and matter? Like and subscribe to the channel. Become a part of our crew. In this cold cosmos, we hold together until the last atom dissolves into non-existence. Your opinion is also part of that great information network that we call the universe. Until we meet at the edge of cognition.